So cosmic black hole. So in 1687, the English scientist Isaac Newton published his monumental work, Philosophiae Naturalis Principia Mathematica, Mathematical Principle of the Natural Philosophy, containing his theory of gravitation and the mathematics to support it. In essence, Newton's laws of gravitation stated that the gravitational force between two objects, for example, two astronomical bodies, is directly proportional to their masses. Astronomers found that it accurately predicted all the observable data that the science at the time was able to collect, with one exception, a very slight variation in the orbit of the planet Mercury around the Sun. It was 228 years before anyone was able to offer a refinement of Newton's law that accounted for the shape of Mercury's orbit. In 1915, Albert Einstein's general theory of relativity was published. Using the equation of general relativity, he calculated the shape of the Mercury's orbit, and the results predicted astronomical observation exactly and provided the first proof of his theory. Expressing this very simplistically, the general theory of relativity presumed that both matter and energy can distort space-time that cause it to curve. What we commonly call gravity is in the effects of the curvature. Among other phenomena, Einstein's theory predicted the existence of black holes, although initially he had doubts about their existence. Black holes are areas in space where the gravitational field is so strong that nothing can escape them. Because of the immense gravitational pull, they consume all the light that comes near them, and thus they are black. In fact, neither emitting nor reflecting lights. They are invisible. Due to this, they can be studied only by inference based on observation of their effects on the matter, both stars and gases around them, and by the computer simulation. In particular, when gases are being pulled into a black hole, they can reach a temperature up to 1,000 times the heat of the sun and become an intensely glow source of X-rays. Surrounding each black hole is an event horizon, which defines the area over which the gravitational force of the black hole operates. Anything passing over the lips of the event horizon is pulled into a black hole because the observation of the event horizons are difficult due to their relatively small size. Even less is known about them than about black holes themselves. Black hole exists in three sizes: compact ones called the star mass black hole, which have been known to exist for some time, are believed to be the result of the death of a single star. When a star has consumed itself to the point that it no longer has the energy to support its mass, the core collapses and forms black holes. Shock waves then bounce out and causing the shell of the star to explode. In a way that is not yet understood, the black hole may be then re-energized and create multiple explosions within a few minutes of its existence. So-called supermassive black holes, also well documented, contain the mass of millions or even billions of stars, and just recently one intermediate black hole with about 500 times the mass of the Sun has been discovered. Scientists have postulated that the interior black hole may provide a missing link in understanding the evolution of black holes. Current scientific data suggests that black holes are fairly common and lies at the center of most galaxies. Based on the indirect evidence gained using X-ray telescopes, thousands of black holes have been located in our galaxies and beyond. The black hole at the center of the Milky Way, known as the Sagittarius A, pronounced A star, is a supermassive one, contained roughly 4 million times the mass of our Sun. Astronomers suggest that the orbiting around Sagittarius A, 26,000 light years from Earth, may be as many as tens of thousands of smaller black holes. One possible theory to explain this is that the process called the dynamical friction is causing stellar black holes to sink towards the center of the galaxy. It is thought that the first black hole came into existence not long after the Big Bang. Newly created clouds of gases slowly coalesce into the first stars, and these early stars collapse to give rise to the first black holes. A number of theories propose that the first black hole was essentially seeds, which then gravitationally attract and consume enormous quantity of matter found in adjacent gas clouds and dust. These allowed then to grow into a supermassive black holes and now sit in the center of the galaxy. However, a new computer simulation proposed that such growth was minimal. When the simulated star collapsed and formed a black hole, There was very little matter anywhere near the black hole's event horizon, being in essence star. It grew by less than 1% over the course of its first 100 million years. The new simulation do not definitely invalidate the seed theory, but they make it far less likely. On the other hand, it is okay เห็นไหมลูกไม่มีอะไรเวลาเราอ่านวิทยาศาสตร์ใน IELTS นะคะมันก็จะแบบบอกก่อนพูดถึงอะไรทุกครั้งเลยเกริ่นที่มาแล้วก็จะบอกชนิดของมันแล้วก็บอกว่า what is so interesting about it แล้วก็ the end มันเป็นอย่างนี้ตลอดลูกเราเรียนกันมาเข้าใจปะขนาด black hole ก็ยังสไตล์เดิมเลยเนาะที่มาของ black hole ความไม่น่าเชื่อของมันแล้วก็ชนิดของมันแล้วก็โอเคอะไรพิเศษเกี่ยวกับมันไหมเราก็มาดูโจทย์นิดนึงนะครับเห็นไหมโอ้หมูตู้เห็นไหมลูก35ง่ายมากผมกลับไปดูนะลูก Sagittarius A ก็อยู่ในตรงนั้นเลยที่มันบอกเป็น supermassive black hole เนาะคราวนี้มาดู true false not given นิดนึงนะครับคีย์เวิร์ดพวกนี้ก็ไม่มีอะไรเลยลูกดูเห็นไหมเราดู not certain นี่คือคีย์เลยมันพูดถึง Big Bang แต่ไม่ได้บอก not certain นี่หว่าเห็นไหมแต่แน่นอน38 according to the seed theory กล่าวถึงเป็นไปไม่ได้ not given มัน given แหละแต่ว่าเราต้องเช็คอย่างนี้ first black hole eventually became supermassive ป่าวเข้าใจไหมแล้วก็ seed theory อีก proven true by computer simulation กล่าวถึงเหรอแน่ใจเหรอเข้าใจป่ะไม่อันนี้ไม่ใช่ not given แต่เราต้อง double check เนี่ย proven true ไหม black hole that existed in early universe were all compact well อันนี้ก็ง่ายแล้วลูกมีการกล่าวแต่แค่ต้อง double check ตรงนี้โอเคไหมครับอันนี้โอทำให้พี่เลยค่ะมา
You are now muted.
Do we see? Yep. Hey, 5 ตอบ B ใช่36ตอบ A ไหมถูกเห็นไหม37 not given ใช่เห็นไหมนะครับผม38ตอบ true ใช่39ตอบ false ดีมากเห็นไหม40 false นะครับจัดการเวลาเห็นไหมทำไม่ดีเราแม่นมันถูกก็ไม่มีปัญหาอะไรเห็นไหมโอ้พี่บอกแล้วมีคำถามเลยมั้ยแต่พี่ว่าไม่น่ามีเนาะมันน่าจะเคลียร์แล้วถูกไม่มีอะไรผิดเลยถูกหมดเลยโอเคเนาะดีมากครับผม